First of all, they also thank the ICPP committee for its recognition of our work. We are a computer research team from the National Defense University of Science and Technology. Next, please allow me to introduce a work on realizing massively parallel in the smooth particle hydrodynamics methods. In computational fluid dynamics, machine-based methods have important application in aerospace, in engineering, development, and safety protection. With the developing of the application, grid-based methods gradually show some disadvantage. For example, in field involving large deformation and free surface fluid, the calculation accuracy is obviously insufficient or even unable to be calculated. Smooth particle fluid dynamics is an important numerical discrete method in computational fluid dynamics. It can be deal with large deformation, explosion, and impact, which are difficult to deal with by grid methods. This method was first proposed by Moynihan in 1927 and used to solve the evolution of planets in open source space boundary. At present, this method is widely used in various fields, and the related code has been a development. One of the most famous SPH open source software is DualSPHysics. Its calculation process is divided into three main modules: neighbor list, particle interaction, and system update. Their relationship is as shown in the figure. At present, use MPI to realize SPH DFS great challenge. This first problem to solve is the distributed storage of particle. It's need to distribute all particle equally to different nodes so as to efficiently maintain the load balance of each node. Secondly, in the storage of domain decomposition, each process will assigned to solution subregion, and each solution region does not overlap with each other. And at the same time, they need to maintain communication. Finally, this is the problem of the load balance. In the implication of SPH method based on MPI parallelization, the storage of particle information is a very difficult problem. The SPH series structures only need to set fixed lists an area to store the particle information, including the density, velocity, and the position of particles. For parallelization SPH, it's need to use the dynamic area as shown in the figure and apply for a large area, including local particle and ghost particle. Local particles are not transferred, and the ghost particle may cross into adjacent process. The ghost particle is followed by the received memory space, which including that the transfer ghost particle will not cause the area to across the boundary and cause memory overflow. Region being Division is also an important feature of SPH parallelization, since each process only calculated the particle of the center part. It needs to issue that the solution domain is divided to a process where we are realizing parallelization. In the domain decomposition of dual physics, each process assigns the same particles, and they are responsible by different process. As mentioned earlier, this is no overlap between region. The implication of particle interaction based on MPI parallel SPH method is very important, which is the booklet restricting performance application, as shown in the figure. Firstly, the particles are divided into central parts and the boundary parts according to the distance from the boundary. Firstly, the particles in the central parts are calculated at the same time. The transmission ascent method is used to realize data transmission. Finally, the particles in the boundary parts are calculated. Therefore, the communication of the boundary part is hidden. It requires that the relation of particle to central part to keep it small enough. Otherwise, the transmission of particle has not been completed after the calculation of the central particles, and the program will wait. This is a key to obtaining the linear acceleration ratio. This process has a communication process of the parallel SPH methods. Here, take three processes as an example. First, the data is distributed to different processes through the domain composition algorithm and then initialize. It can be seen from the figure that there will be 4 communications in each iteration. Here, the load balance condition of 4 presses and 8 presses are sure that it can be seen that each process will dynamically adjust in internet within 100 time step to ensure that the overload load balance is maintained at a relative stable level. After implement MPI parallelization, this paper adapts some optimization methods such as communication hiding technology in the phases of particle interaction and particle cross-process transfer. So, in the weak scalability test, each computing core undertakes 50,000 to 100,000 particles, and its weakly scalability still performs well. This paper introduced the process of parallelization of famous CFD software, dual physics. We solve some problem as follows. The parallel version of SPH need to solve the problem of the storage structure, region decomposition, and the load balance. At the same time, our future work is to develop large-scale